Section 2.3, Truth Tables, Negations, Conjunctions, and Disjunctions, Video 1. The objective we will cover is construct truth tables with two simple statements that include negations, conjunctions, and disjunctions. Truth tables can be used to identify the truth values of statements. Statements can be either true T or false F, and can be simple or complex. Given a simple statement P can be either true or false, but not both. Below is the truth table for the simple statement P. Recall that the negation of a statement has the opposite truth value from the original statement. The negation of P is often read as not P. Statement P and not P can be represented using a truth table. So if statement P is true, not P must be false. If statement P is false, then not P must be true. Truth tables for two statements. Given two statements P and Q, there are four ways to represent the truth values. This can be represented using a truth table. The first case, P and Q are both true. Second case, P is true, Q is false. Third case, P is false and Q is true. Fourth case, P and Q are both false. Each row of the truth table is referred to as a case. When working with two simple statements, there will be four cases. Going forward, we will always represent our statements P and Q in the order the truth values appear. Truth table for conjunction statements. Recall that a statement using the connective and is called a conjunction. The conjunction of statements P and Q can be represented as P and Q. Given statement P is true and statement Q is true, statement P and Q would be true. If statement P is true and statement Q is false, statement P and Q would be false. If statement P is false and statement Q is true, the statement P and Q would be false. If statement P is false and statement Q is false, the statement P and Q would be false. Suppose you are given the following statements. Michael went to the gym. Michael went to the beach. There are four possible cases for the statement P and Q. When looking at each of these cases, make sure you refer back to the original statement P and Q. So for case 1, Michael went to the gym. This means P is true and Michael went to the beach, meaning Q is true. The statement P and Q is true. Case 2, Michael went to the gym, so P is true, and Michael did not go to the beach. In this case, statement Q is false. The statement P and Q is false. Case 3, Michael did not go to the gym, so P is false, and Michael went to the beach, meaning Q is true. The statement P and Q would be false. Case 4, Michael did not go to the gym, meaning P is false, and Michael did not go to the beach, meaning Q is false. The statement P and Q is false. Truth table for the disjunction statement. Recall that a statement using the connective or is called a disjunction. The disjunction of statements P or Q can be represented as P or Q. Here, if P is true and Q is true, then the statement P or Q is true. If P is true and Q is false, the statement P or Q is true. If P is false and Q is true, the statement P or Q is true. If statement P is false and statement Q is false, the statement P or Q is false. Suppose you are given the following statements. John is going swimming. John is going to run. There are four possible cases for the statement P or Q. Again, always refer back to the original statements for P and Q. So case 1, John is going to swim, so P is true, or John is going to run. Q is true. The statement P or Q is true. Case 2. John is going to swim, so P is true, or John is not going to run, so Q is false. The statement P or Q is true. Case 3. John is not going to swim, so P is false, or John is going to run, so Q is true. The statement P or Q is true. Case 4. John is not going to swim, so P is false, or John is not going to run, so Q is false. The statement P or Q is false. Now notice something between the two truth tables, the conjunction and the disjunction. Notice that the only time a conjunction statement is true is when both P and Q are true. For all other cases, the conjunction statement is false. For the disjunction statement, notice that the only time the statement P or Q is false is when both P and Q are both false. All other cases are true. This ends video 1.